Hello, listeners. Welcome back to Exploring the World with the Doll Potato Sisters.
You know, while we were editing the clippings, we came across audio that was saying, bottom of the ocean, ocean to the seafloor.
Doesn't it sound like rap? Bottom of the ocean, ocean to the seafloor.
Anyway, that was so random, but today we are going to be talking about the dark and the mysterious.
Hey, I want to say what this episode is going to feature.
Wait, I haven't even said what the topic is.
Whatever. This episode is going to feature jellies longer than blue whales.
You always struggle with that word.
The deep sea!
Hey, Isha, it was supposed to be mysterious.
Fine. So anyway, the deep sea is basically a part of the ocean where there is little or no light. This begins to happen around 200 meters deep.
Since the deep sea is so far down, it is dark and cold as sunlight can't really warm the water up. And there's a lot of ocean pressure there.
What do you mean ocean pressure?
These depths of the water actually can range to having 40 to 110 times more pressure than Earth's atmosphere. Ocean pressure is basically something called hydrostatic pressure, which occurs when the weight of water above you pushes down because of gravity.
Yep, and the pressure can be so intense that if a human were to go really deep, it would be highly likely they would be crushed because of the pressure.
Wait, but why don't we feel it when, say, I swim at the beach?
I find this part really interesting. When we are at sea level, we actually do have pressure pressing against us. Actually, it's around 14.7 pounds per square inch. And is that just me, or does that sound like a lot of pressure?
It's not just you. It's just we don't feel the effects because the fluids in our body actually are able to push back with the same force.
Wow!
I know, right? It's amazing what our bodies can do without us even realizing it. So basically, approximately every 33 feet, the pressure increases by the unit of 1 atmosphere.
So why don't the deep sea animals like whales have trouble with the pressure?
So actually, many of the animals that dive down to the deep to find food have lungs that can collapse safely under pressure. Fun fact, the reason they're able to do this is because they have a flexible rib cage and are bound by cartilage.
Cartilage?
Cartilage is the material in which our nose is made out of and what sharks' bodies are made out of.
Oh, my nose.
Yup. Hey, for more information on this topic, I invited Mr. Justin to come talk to us.
We were wondering if you could tell us where do you work and what's your title, and if you could tell our listeners some details about your job.
Sure. So, hello everyone. My name is Justin, or Mr. Justin. I work for Greater Farallones and Cordell Bank National Marine Sanctuaries as an education specialist and as the visitor center manager. So I get to look after a visitor center in San Francisco's Presidio, out kind of in Crissy Field. Folks are welcome to come visit the visitor center. It's a little bit like a small museum that is open Wednesday through Sunday, 10 a.m. to 4 p.m. And there's no charge to come visit.
And
wow. So some of the things I get to work on are like school programs. I do a lot of teaching and coordinating of field trips. Sometimes we do fun family workshops on the weekend. Just all different kinds of school programs and public programs. And I get to work with a team of educators and outreach folks, and also our broader team who all work to help protect our amazing national marine sanctuaries throughout the country.
Thank you. So can you just tell us what is categorized as a deep sea?
Yeah, that's a great question. So sometimes people think of the deep sea as like kind of the top 200 meters of so of the ocean are known as like the sunlight area. So the kind of the top part of the ocean. that top 200 meters might be the sunlight area. And then our plant-like plankton and some of the bigger algae. I know you've done some work or some podcasts on kelp, like that's kind of in that upper area. Then as we get deeper, kind of at that 200 meters depth, which is, around over 600 feet, you get into that twilight zone as you're going deeper and deeper down, where the light starts to decrease pretty quickly. And then as you get really into those deep waters of like greater than 1,000 meters, things are almost completely dark and you don't have photosynthesis. But that's kind of like a more technical definition of deep sea. People use deep sea for I think waters that are not quite as deep. Even we do in our sanctuary program sometimes. Sometimes we talk about deep sea benthic habitats or deep sea habitats that are on the shelf off of the coast of San Francisco and off the coast of the Bay Area here.
Thank you. Do you want to ask this
yeah.
one?
How does having a deep sea habitat affect the rest of the ocean?
Yeah, like the deep sea habitat up where I'm at near the Greater Farallones and Cordell Bank National Marine Sanctuaries. I mean, it's amazing. These habitats, they have like colorful corals and sponges and lots of species of fish and just lots of cool invertebrates. So some of the things that deep sea habitats do, they can provide food and shelter. They're just really productive habitats. They can be filtering services. And lots of these animals just do really important ecosystem functions that just make it's just really important to the health of all the ocean habitats around them. Something that might be a whole nother podcast someday that we're learning more and more about is something called blue carbon. So learning about the important role that deep sea sediments, like the soils or the sediments, the sandy bottom of the deep sea, how they can be really important for storing carbon. So these are some of the reasons why they're so important.
So where are we now on studying blue carbon?
Like the term blue carbon, it's kind of a newish term. It's just talking about the carbon that's captured by the world ocean and coastal ecosystems. So it's not new. That carbon has been stored in those sediments for ages. But really learning how it's part of the carbon cycle has gotten a lot more interest. And looking at ways that we can kind of make sure that those sediments that store a lot of carbon stay kind of undisturbed by things that humans might do that might let some of that carbon kind of back into the system.
Ria and I researched about the animals that live there and how they survive extreme pressures and scarcity of food. How have they adapted to these challenges?
I'll give you a couple examples or some thoughts, and I'd also love to hear if either of you have a favorite story, because there are so many interesting adaptation stories with the deep sea. Let's see, how about creatures who live at great depths? They often don't have pockets of air in their bodies. Things like swim bladders that you'd find in a lot of fish that are in more shallow waters. And so without air in their bodies, it kind of solves the pressure problem so that like fish and crab and octopus and some of the worms and different types of shelled mollusks that are in the really deep ocean, that's one of lots and lots of different kinds of adaptations that comes to mind to share with you. Animals have to eat in order to stay alive. I hope you both had a great lunch today, an afternoon snack. I know I did. So the majority of life on Earth, it's really like it's based on this food chain that revolves around sunlight. And so we're talking about how in the deep sea there isn't a lot of sunlight making it to those depths. So how does it work? So for environments like the deep ocean that are completely dark, or in some of the kind of middle, almost deep sea areas, there's this stuff called marine snow. And it's like dead plants and animals and plankton, which I know we're going to talk about later in this podcast. It's all this stuff that just sinks down from the top of the super productive surface layers of the ocean. And as it drifts down to the seafloor, that's a real important source of food for the deep sea. And then other animals have found like completely different ways to survive down in the deep sea through a process called chemosynthesis. And chemosynthesis, that's when like animals will have bacteria or other organisms that use the chemical energy from maybe sulfides or methane, different kinds of chemical compounds, and they use those to produce food. So when I was an undergraduate in college, I had a chance to study at a marine lab down in the kind of Monterey Pacific Grove area. And I got to study deep sea clams, and I was doing a comparison study in a professor's lab looking at two different species of these deep sea clams that had different amounts of a bacteria in their gut or in their tissues that could basically use the methane. I think it was the methane that was seeping out from these cold seeps and use that as its energy source. And so we were looking at some of the clams are really close to this cold seep and some of them are further away, and maybe that tells us something about how much of this bacteria they have in their tissues. So that's another way that they'll deal with scarcity of food. But there's also lots of other techniques, like if there's not a lot of food around, maybe you can attract food to you with bioluminescence or other strategies like that.
So, I was wondering, um, so what is when these animals like kind of use methane as like a food source, parts of the methane, does this like somehow contribute to like helping or situation with global warming or something?
Right, because when you think of methane, you think of it as a very like effective greenhouse gas at trapping heat in the atmosphere. That's kind of where you're thinking.
Yeah.
Yeah, that's a good question. I'm I don't know the like what the connection is offhand of like from a cold water seep, say in like Monterey Canyon, where this dissolved methane is coming out, like what that connection is to the atmosphere.
Mm-hmm.
But maybe some of these organisms, by using some of that methane, maybe they are capturing it and helping the bacteria, or helping those clams, or there's a number of different species that do this, and maybe that does keep some of the methane out of the atmosphere.
Can you tell us about how
Chemosynthesis works. Could you elaborate on that, please?
So again, I'm not an expert on this, but some bacteria are kind of just like free living colonies that get eaten by other animals. But there's other chemosynthetic bacteria that have symbiotic relationships with larger animals, and they live directly in the tissues of these animals. And so together with these bacteria, they can they form the basis of the food chain in places on the seafloor where sunlight may not reach. And these are usually around hydrothermal vents, like the really deep and really hot vents.
Mm-hmm.
Ones that we call cold seeps, which you can find right in Monterey Canyon. Even things like around whale carcasses, like when whales die and sink to the bottom of the ocean, into the seafloor, that's another place where you find these organisms.
Mm-hmm.
So even things like that. But yeah, it's just like how some animals are, some like plants or kelp or algae or phytoplankton, they are built to do photosynthesis. These bacteria are built to do chemosynthesis.
what is your favorite animal in the deep sea?
Oh my goodness. So many to choose from. Um, Usually I'm a big invertebrate person, so I would often say I really like some cool octopus that lives in the deep sea or something like that. But I have to say I really like sperm whales.
Ooh.
I think they're really interesting, and they hunt for food during like really deep dives. They can go, like frequently like 2,000 feet. They can dive for like 45 minutes, and they're able to like maybe like a most extreme depth they could go is to go 10,000 feet for over an hour on one long dive. And they're amazing. They can go these deep dives, then they'll kind of come up to the surface to breathe and recover for a few minutes. And then they'll go and do their next dive. So, because they spend most of their time in the deep sea, their diet, the things that they like to eat, are things like squid and sharks and skates and fish that are also in the deep ocean waters. So maybe I relate to them because I think they get to go down there in search of other life and kind of like because they're hunting for food, and they probably kind of get to see it all going down to those depths. Um, but unlike some things that live in the deep sea, they also get to come to the surface and all the water column in between. So they're not just found in the deep sea, but they are one of my favorite deep sea animals.
Have you been on any of NOAA's deep sea exploration or any others?
So I've had a few opportunities. There's a boat called the Nautilus. Have you heard of
Yes.
Nautilus?
Oh,
Yes.
The So I've been on the Nautilus boat while it was in harbor. Like I've been able to tour it. But during the pandemic, when they didn't have as many people allowed on the boat, they did still have educators like myself who would take turns taking questions from, if you've watched it, people will type in questions, and then we have the like kind of satellite link through our computers to the researchers. And so I got to be like a moderator and help bring questions to the public from all over the world.
That's
I would often get to do like 2 in the morning our time till like 6 in the morning, or
wow.
2 in the morning till 4 in the morning, and it was kind of fun. So some of the people that were watching were like in Australia or China or like all the way on the other side of the globe. That was really interesting. And when I did that clam research, I actually got to go out on one of the Mbari boats. So you know about in Monterey, there's the Monterey Bay Aquarium Research Institute,
Yes.
Mbari, and
Yes.
that was with Professor Dr. James Barry, or Jim Barry, was our contact. And so that was we used the pilots used the ROV to collect the clams that I got to take back to the lab to do research. So that's from my undergraduate days. That wasn't a NOAA boat, but we're getting ready. I mean, we're getting packages at my office for the Shimada, which is a NOAA boat that's about to do some work for Monterey Bay and Greater Farallones and Cordell Bank National Marine Sanctuaries. So there's a research cruise getting ready to go. So I have had a chance to kind of be part of them, but I haven't been out on any of the NOAA boats for like overnight days, more for like day trips. On one of our boats is called that we get to use is called the research vessel Fulmar, named after the seabird Fulmar.
Ooh.
And been out with teachers or just out with scientists, partners on that boat before.
So do you know what you're? Do you know and what's the most recently new found deep sea animal in the deep sea?
Yeah, what's the most recent? So that's this is an interesting question. It's kind of a weird answer. I was walking with my 10-year-old son on the beach over by the Golden Gate Bridge. So this very beautiful, kind of quiet beach that a lot of people don't know about. You can only walk on it when the tide's pretty low. And so there was a fish that was washed up on the beach, and I might be incorrect in my identification, but I'd just been looking at a lot of the video from these NOAA and some of the Nautilus footage, and there's a fish called a snail fish that you might have seen or know about. They're really interesting. And this fish that was washed up on the shore looked a lot like a snailfish. And so I was wondering if it was. I took some pictures and sent it to my friend who's a NOAA fisheries biologist. And he was like, not sure, but maybe that might have been the most recent deep sea animal that I got to encounter.
That's so cool.
So, what animals live down in that deep, dark place? Whoa.
Dark? It's hardly that dark there where there are a bunch of animals.
Huh? What do you mean?
A lot of the animals there use bioluminescence. At least the permanent residents do.
Bio what?
Bioluminescence is a chemical most animals make when they live in the dark environments. Bioluminescence happens when a chemical reaction happens in the organism's body.
So, what causes this chemical reaction to happen?
The chemical reaction can happen when the organism has molecules in its body called lufersin. It's a special molecule that gives out light when it encounters oxygen. We call this light bioluminescence.
So, does this only happen in the ocean?
No, actually, bioluminescence can happen anywhere. Fireflies use it, glowworms use it, and even fungus.
Can you tell us more about how the animals down there use bioluminescence? We'd love to have some information, fun facts on how bioluminescence became an adaptation for sea animals over the centuries.
So, some of the ways that animals use bioluminescence, we talked about a few of them when we were talking about your favorite animals. They can use them for defense. When we teach a lot about great white sharks for the greater Farallones because it's a really important environment for great white sharks, and we talk a lot about how great white sharks have white stomachs, white tummies, and that's called countershell, or a sea lion that doesn't want a great white shark to make lunch out of it. If they will look up and be like, I hope there are any sharks up at the surface. And the white of the shark, if you've ever been down in a swimming pool and looked up on a sunny day, it's kind of like white. It's like white on white. So it's like really good camouflage. And some animals use bioluminescence, especially in the kind of twilight area where there's some blue light that makes it down. There's a little bit of blue light. Some organisms will have like that blue luminescence on their underside. So if somebody's looking up, either maybe because they're looking to eat something and they see the shadow go across this background of like shimmery blue, that shadow gives them away. So to not have that shadow, some of them will try to match the like low blue light with using bioluminescence, which I think is amazing. I think it's lanternfish it's hatchetfish that do this. I think hatchetfish will do this to try to not become prey. So one way is definitely for defense. As you know, because I think you are cephalopod enthusiasts like I am, that squid can like shoot out bioluminescent like shapes instead of like a regular ink, and that can even get on like whoever was chasing them, and then everyone can see them because they got covered in bioluminescent goo or ink. Suddenly they're gonna be attracting or luring predators. Can be used for to find food. So we use the anglerfish example of like trying to lure in food or things that are attracted to certain lights. And even to like find a mate. Lanternfish have different flashing patterns for males and versus females, and it might help them find a mate. So those are just 4 different ways that kind of come to mind, but defense, camouflage, finding food, and finding a mate. But it's pretty incredible. And yeah, your other question is sort of how did bioluminescence evolve kind of through time? That's a really good question. I'm not an expert in that. I just I know that it's a chemical reaction that ends up releasing photons of light in that reaction. So it's when you take that molecule and then that enzyme and then combine them, it gives off that light. But the fact that so many different animals have evolved the ability to do that across lots of different groups, right? It's like it's not just fish, right? There's also invertebrates that can do it. It's just interesting that so many of these species are able to do that.
Thank you.
How much percent of deep sea has been explored by the scientists?
Whoa, that is a great question. You're thinking like not just locally, but like globally, like
Yes.
Well, I mean, we'd like to know both, actually. Yeah.
Yeah.
Statistics on both.
I mean, I think it also depends on to what I was gonna say to what depth, but that would be a bad pun. Like how well do we really know it? Um, what do we mean by explored? Because maybe we've taken a ship over a big chunk of the ocean to get a sense of where the hills and valleys and mountains are, but we don't know if there's live animals down there, right? So we haven't like we haven't taken a NOAA remotely operated vehicle, or we haven't had the Nautilus team go down there with like cameras and really investigate it. I think probably a reasonable estimate is that maybe we've only explored about 5% of the world ocean. And that's sort of like a rough NOAA estimate that we talk about. So only explored about 5% of our world ocean. And for our local ocean, because there's a lot of biologists and ocean conservationists and lots of sanctuaries right off our shore in California, it's probably a little bit higher, but not a lot higher in terms of having like video footage or having really a good sense of what the habitat looks like down there, because it is expensive to like do research like that to learn more about it. It can be to send down like cameras and ROVs.
So, we
do-
really want to get to the
Planktons, but we just have
Oh, okay. You have one more
one
question.
more.
Okay.
Okay.
Do all the animals in the deep sea use bioluminescence? If not, what percentage do?
I think I can just answer the first part of that. Maybe we'll have to do some research together to answer that second part. Not every animal in the deep sea uses bioluminescence. So yeah, in terms of what percent do, it probably depends a lot in what area. I bet it would really vary depending in what part of the deep sea you are in the world. But yeah, what percent of deep sea animals have or use bioluminescence? Gosh, do you have a guess?
I'd say 95.
I would say maybe
Percent?
like 9
Yeah.
and 1% don't.
What is the NOAA?
Okay, that's great. I did find like a reference from MBARI, who I mentioned before, the Monterey Bay Aquarium Research Institute, and in their research they found nearly 75% of deep sea animals can create their own light. Wow. So you're all pretty darn close to their estimate.
Oh, that's really cool. So then what percentage of animals primarily rely on bioluminescence then? Is it like, yeah. Do you have any statistics on that number?
You mean like once we leave the deep sea?
Well, no, like you said how like 75% are able to make their own bioluminescence, but what percent actually relies on it, whereas some can just make
Oh, I see what you're saying. Yeah. My guess is that there's probably some purpose or advantage to their bioluminescence. So I would guess it would be almost all of them.
Hey,
What?
I always love hearing about the weird animals.
Oh, yeah.
And from the videos I have seen of the deep sea, there are so many.
Okay. Let me tell you about my favorite animal.
Of all time?
Yep. So this animal is called... Hello, where's the suspenseful drum roll?
Oh, yeah.
A siphonophore! Siphonophores are a type of jellyfish that are made out of different organisms. There are 175 types of siphonophores. My favorite ones are the common siphonophores that live in the deep sea and the Portuguese man-of-war siphonophores. They can actually grow to be longer than a blue whale.
What? Aren't blue whales like the biggest / longest animals on the planet, though?
Though the siphonophores are actually longer, scientists don't count it as it's made out of different organisms.
Quick vocab definition for listeners. An organism can be categorized as a plant, animal, or even a single solid form.
Yep, the organisms actually all work together to get food. A really cool fun fact I love to share with listeners about this animal is that the deep sea siphonophore will get bigger and bigger and burst if it goes above the midnight zone.
Oh yeah, I remember we talked about those ocean layers. If you want to learn more, listeners, check out our very first episode.
Meaning not the intro one.
Yeah, the one after that one.
I haven't really talked about the Portuguese man-of-war yet.
There's more! Also, doesn't the Portuguese man-of-war live at the surface of the water?
Yup, but I am at a roll with these siphonophores, so I'm going to keep talking about them.
I call reading this part. The Portuguese man-of-war can have tentacles up to 30 feet long. Their stings can be fatal to other organisms in the water.
Actually, not for all of them. A fish called the Portuguese man-of-war fish actually is immune to its stings and spends most of its days hiding from predators in their poisonous tentacles.
So, Mr. Justin, why do we have to conserve and protect this place?
We were wondering, how is microplastic affecting the deep sea currently? And if it's not plastic, what are some threats that people may not know about? Is it like microplastic, normal plastic? So can we have some more details on that?
Yeah, that's a great question. I mentioned that we're doing one of our access research cruises that's coming up. And part of the protocols, part of the research on that trip is going to be taking some microplastic samples. I don't actually know for sure what depth they're going to be sampling at. I know that with, I think on some of the Nautilus cruises, there was some sampling right at the surface, like some little surface cores looking for microplastics. That was one of the students' projects who was involved in that cruise, the one that I was involved in. Also, I think a lot of times people do microplastic surveys at the surface, since a lot of microplastics float. That's a good place to look for them. But I know that that's going to be part of this cruise. So in terms of the globe, I know microplastics is, and plastics in general, is a big ocean concern. In terms of plastics in general, things like bigger organisms getting entangled in plastics is a big issue. Everything from like whales to pinnipeds like seals and sea lions, or birds. But then just finding plastics working their way up through the food chain, even getting connected or involved with plankton, and then things that ingest plankton concentrating those plastics in their body and in their tissue and moving up the food web is something that we're concerned about.
Is there any like specific types of plastic pollution that is affecting the deep sea specifically though? Or is it just like a global every habitat?
I think most of what I hear about is more the extent that microplastics have been distributed. I think bigger and heavier plastics that sink are less likely to kind of make it out to the deep sea unless they're being maybe dumped from a vessel. But little tiny drifting microplastics could travel really, really far. And so I think people have been concerned that you can find microplastics in environments that just seem like they're really remote, like a distant from land deep sea trench.
And we were wondering, how does the health of the deep sea affect the rest of the ocean? Can you tell us more about that relationship?
Those animals that live in the deep sea, like some of them provide, say, like habitat, like things like corals and sponges provide really essential habitat for fish, and fish need that deep sea habitat because that's where they like to hang out. They are an important food source for lots and lots of animals, including humans. And if you don't have those habitats, then you can't support those fish populations. So that's that's one example. And it's also just an area where, as I mentioned, that carbon can be stored like in the top sediments. And it's the hunting grounds of things like my favorite animal, of like sperm whales going down there looking for big squids and skates and other things like that and fish.
Listeners, which animal was your favorite that we mentioned in this episode? Be sure to write in the comments.
Also, I don't know if you caught this, but remember Mr. Justin said we'd be talking about planktons in the episode? Well, we tried to edit it, but it was like so long. So we decided that instead we would put it in a sub-episode, which will be coming out soon.
Bye!
The sound effects were provided by Freesound, and all information was provided by NYA and from Monterey Bay Aquarium.